everybody. So I'm here at the Living Computers Museum and Labs in the lab section, and I'm doing a demo with microcontrollers off and back over here. So let's see what those microcontrollers are. So these are a bunch of different microcontrollers that I brought that I use a whole bunch. So this was a development board that was given to me a while ago. I'm not even sure if they make the chip anymore, but this is, if you go to college or do professional training for programming hardware, this is likely what you're going to be doing a bunch of stuff on. And then these are some older computer processors, which are microcontrollers as well, that I got from the museum up here to show off. And these two are a microcontroller I use quite a lot called the AT-Tiny 85. It's basically a really small Arduino. And then these are the Arduinos. This is a Arduino with a removable Atmel32 microcontroller, and this one uses the 32U4 microcontroller. And then under the microscope, I've got a few other boards. So this one that I'm showing off right here, this is a microcontroller that is on a sound effects board for Adafruit. If we go down a little further, so this is a memory chip. Basically has flash memory. I believe this one is about 2 megabytes of flash memory, if I remember correctly. But this is the critical microcontroller here. So what this does is it basically takes audio files, specifically MP3 files or OGG files, and it converts them into audio that can be playable using the headphone jack here. This one does not have an amplifier built into it, but yeah, this is the conversion chip that allows this thing to play MP3 files. So if you have something like an MP3 player, you probably have a chip similar to this inside of it. And then over here, I have the data sheet that I pulled specifically for this chip. So this is what the data sheet looks like. This is specifically the part that shows the architecture of the chip. So all the different functions that go together. Data sheets tell us all the information we need in order to write code, including the footprint and the different types of configurations these come for. Oh, you know what? I'm sorry. This is not this is the 32U4. So this is the audio chip. And the data sheet for that. So this will give us all kinds of information as to like what types of signals we can send, some best practices when it comes to code. I'm going to find usually it'll have some benchmark data. So let's see. I think, yeah, so this is kind of some suggestions for use. A lot of data sheets for stuff like this, they'll actually give you a schematic or a suggestion for what you use. It looks like this is just a simple MP3 player. So our chip is there. That is likely just a massive amount of flash memory for that device there. And then I think on this one, if we go to the top, that has our benchmark settings, which usually just give graphs of the type of signal you would send to it. There we go. So this is basically telling you how some of the signals are interpreted if you're using a meter to test on this, an oscilloscope, and what kinds of info you should probably see on that. Data sheets are super useful. The other thing I've got, so this is another chip, which is on actually a game controller that hooks up to the Raspberry Pi. This chip basically interprets a lot of data that we'd use for like a game controller. And And then, of course, you can purchase these chips on websites like Mouser or DigiKey, and you can see, hopefully, yeah, the price range on some of those. So, I mean, microcontrollers can get to be pretty inexpensive, which is why we use them, and they're low power, and they do quite a bit. So that's it.